A crowded room, ICP, challenges of ICP, yeah, maybe a little bit scientific, but I try to give you a brief introduction on how ICP OES or ICP MS works, and then follow up with some examples of the challenges in ICP, because it's not so easy like maybe people think it is. And in the second or third part, we ask the question, is it the best way to determine more and more elements in salt water by ICP? Maybe there are some alternative considerations we can think about. Okay. A little bit theory. What do we have? We have our salt water or our salt, and we need to transform this salt in something which we can measure in a machine. So this is called ionization or an excitation of the molecules of the free atoms. And then we are able to measure them. It's quite simple. The ICP, which is the inductively coupled plasma, we've got a sample, a little pump where we can transport the water into a nebulizer, and what is the most important thing is we have an ionization source. So we have to make our salt, our molecules, to ions, and then we have the MS, which is mass spectrometry. So we measure the mass of certain molecules. So iron has another mass than manganese or magnesium or calcium. And this is what we can detect at the end, how many molecules of a certain mass we have in our solution. Same thing for OES. Again, we have our sample, the pump, and an ionization torch there. But in this case, it's an optical emission spectroscopy. So we just measure light. Yeah? We measure a certain wavelength of light, which is characteristic for this certain element. So the less elements we have in our sample, the easier it is to get a characteristic wavelength out of this. So maybe it could be very easy. We have ICP MS, ICP OES. The one goes on a special mass of the molecules or ions, and the others, the OES, is the optical thing that emits a certain wavelength which we can measure. And generally, both systems should be able to analyze the whole periodic system of the elements. Of course, that doesn't work. And these are the challenges we have in ICP. Yeah? We are not able to measure each element the same precise like the others. And these are the challenges. So let's go into the challenges. Easiest, most hobbyists think that the value of ICP is something God-given. And I need to tell you it's not, right? And here are some thoughts or considerations on where ICP analysis reaches its limits. First is the device is only as good as its operator. That's always in life, right? If the guy doesn't know what he's doing for sample preparation, for interpretation of the values, you get at the end a wrong value. So it's always, the device is only as good as its operator. And of course, the result is only as good as the technology measuring it. There are different machines, one is Spectrum, LED, whatever. There are different companies and different ways how to set up these machines. And salt water is one of the most difficult matrices to measure. So most people in ICP for salt water use the Spectrum machines because they are specialized on this. So the machine is or the technology is very important for your results. Then we have something what we call maybe environmental pollution. Yeah? A lot of elements which are important in our tanks we already have in the air, and the sample goes in the system with some air. So For example, sodium we have everywhere in the air. In very low concentrations, but that matters. Or zinc, other heavy metals, depending where you are, in the countryside, in town. So it's very important to check where you put your machine, where you put your device, how clean or not clean is the air around. So when you establish such a machine, you should have a really clean room with filters on the wall. One more thing which is also important, we work with high salt concentrations, right? We have 3.5% salt in our tanks, so this can easily lead to salt contamination in the system, right? We dry this water out, so we get these plugs there. So cleaning is one of the most important things, but everybody wants to get his sample very fast. Time is money, so we need to make clear that the systems get cleaned after each vial, after each measurement. Yeah? So 50% of measuring is cleaning the system. And of course, another thing is pricing. Yeah? We need to say in aquaristic hobby, these ICP measurements are extremely cheap, right? If you do environmental sampling or pharmaceutical sampling, a sample costs maybe 80 pounds or 100 pounds. Yeah? So in aquaristics, we do very low pricing for this, but anyway, MS costs more than OES. It's more expensive because of the technology behind, of the setup of the machine, etc. So pricing is also a challenge. Okay, then, sorry about this, we have sample preparation. Yeah? Sample preparation means we need to think we have a concentration of, let's say, 1,500 milligrams per liter of the main elements and micrograms per liter with the lower elements. So between vanadium concentration and concentration of magnesium, there is 1,000 milligrams difference. So we have a system which needs to measure very, very little and also very high. So dilution is a thing you need to decide. In MS, you have to dilute your samples because the concentration of salt is too high. The machine wouldn't be able to do this. But diluting means also you take a little drop out of a big tank. And this little drop needs to be representative in its concentration for the whole tank. Then you measure it and calculate it back. So that's a high risk getting a wrong result if you dilute too much. Yeah? If you dilute by 1,000 or 100 times, it's a high risk to get at the end a wrong value. Now we got to the more important things which is not so easy to overcome. I said different elements have different energies. Maybe that's not really correct from the chemical side, but it explains it very good. So each element is a little bit different. And just to ionize it, to make it able to measure an ICP, it needs to have the ability to give up the energies. And we see, if we watch the periodic system, on this right part, these elements, only 10% or a little bit higher of these elements are able to be measured in the system, right? So 90% we are not able to measure in the whole matrix. So things like chlorine, bromide, it's not easy to measure in ICP analysis because their energies are not high enough to get to be ionized there. For me, I think the most important thing, the matrix. The more elements contained in the matrix, the more demanding the analysis. It's not easy to find characteristic wavelengths for each element. So the more elements you have, the closer their energetic levels are. So it's not easy to find a characteristic wavelength. And this is what we need. We need a characteristic wavelength for each element. If you don't have this, you cannot make sure that you measure only one element, right? If manganese and iron emit at the same wavelength, you measure them both. Yeah, and you cannot say what's the concentration of that and this. So this matrix and the corresponding method of analysis is the most important thing, I think. So everybody who is doing ICP has to develop its method, how to measure it. Which wavelengths do I use for which element? Let's go back to iron or manganese. You can say you can measure manganese at a wavelength of 143, 145, or 155. Which one do you think is characteristic in your water, in your matrix? And every tank has a different matrix. So you have to find the right method. Salt water made with salt that contains many elements is more difficult to measure. The more elements in the salt, the more elements in the water, and the more difficult this matrix is to measure. For this reason, it's extremely important to find the right method for your salt, for your matrix. Yeah? Find the characteristic and specific wavelengths. Wavelengths is the most important thing at ICP OES. So the method and the differentiation of the manufacturers is the thing which makes the difference between ICP labs. If everybody would work with the same method, everybody would get the same results, right? This is what they do in pharmaceutical industry, environmental science. They try to find one method for one matrix, then this is published, and every lab all around the world is working with the same method. We are quite far away from this in the aquaristic hobby. This is because we have different matrices, but maybe it's also not want that everybody knows which is the best method. But to my opinion, it would be possible to establish a method for one salt or for one special matrix, and everybody all around the world could use this method, and the values would be the same. The results would be the same. Okay. Which challenges did we talk about? I called it simple challenges and difficult challenges. So simple to overcome. The device is only as good as the operator was the first thing. Okay, we need to find an operator who is able to work with the machine. The result is only as good as the technology. Okay, we need to find a technology which works very well. High salt concentration leads to contamination of the system. We have to clean, and we have to overcome the pricing. These are challenges we can easily overcome, I think. Environmental pollution, we need to check. Very important when you establish the machine. But the most important and difficult challenges are different elements have different energies, and the matrix and the method of the analysis. Yeah? Most probably, you will not be able to find characteristic wavelengths for each element. Yeah? In our days, I think we are able to find wavelengths where we can say this value is correct, plus minus 10%, for approximately 10 to 15 elements. But we are measuring about 36, 37 elements in ICP. So, maybe an alternative consideration to overcome major challenges in ICP. ICP OES analysis needs scientific knowledge. On one side, ICP analysis. What do we want to know? We want to know the relevant elements concentrations in our tank. Relevant is magnesium, calcium, potassium. We need to know this. We also need to know the toxic elements. Which concentrations do have toxic or potential toxic elements in our tanks? We need to know about this. But then we have other elements which we are easy can correct because they are low in concentration. We have elements which are difficult to analyze in ICP OES because we don't know the wavelengths. And we have elements which are under the detection limit because they are so low concentrated in our tanks, we are just not able to measure them because the concentrations are so low. On the other side, we have a scientific knowledge about the elements in the water, right? From long time investigations, we know that different elements are consumed in the aquarium depending on each other. For example, there are elements that are necessary in the nitrogen cycle. This is a group of elements, 2, 3, 4, 5, 6, and all these elements are necessary in the nitrogen cycle. There's another group, for example, with elements which incorporate in the coral skeleton, and another group which is essential for the enzymes. These are the heavy metals. So we can find groups in our water, groups of elements which behave proportional in the water, right? If one goes down, the other go down. If one is too low, the other's low as well. So changes in concentration of single elements therefore result in proportionally equal changes in the concentration of the remaining elements in this group. And this is really a knowledge we got from over a long time of period to watch really which elements behave the same. So, but if we know this, we can use so-called indicator or guiding elements to calculate the consumption of several other elements. So the indicator or guide element can be analyzed very well using ICP-OS. We use elements which we know they can be analyzed very, very well in ICP-OS, and then we can dose the whole group. We can calculate the values of the whole group. So what do we want? If you are aware of the challenges of the pros and cons, which I explained a little bit here, you should dose the elements in your tank based on this knowledge. You can dose as a minimalist, right? The minimalist only doses the elements that are important and that can be measured by ICP-OS. It's maybe 13 to 16 elements, and that's fine. You know? He knows them, he can buy them, he can dose them. Or you would like to be a maximalist. As a maximalist, you would like to have all the more than 60 elements of the ocean in a correct value in your tank. Neither ICP-OS nor ICP-MS can achieve all these values today. But maybe we could find an optimized trace element dosing system with the knowledge of science and also the ICP thing. Yeah? So the maximalist, he analyzes all elements in ICP which are able to analyze with an inaccuracy less than 10%. These are the elements we are able to measure very well. Some of them could be guiding elements for similar groups. And then we dose the whole group of these elements. Yeah? We take one element, let's say we take zinc, and in the zinc group are 5 further elements, so we dose this whole group. And maybe you're more correct with dosing with this system, like getting values from ICP. So at the end, to summarize this, matrix or method effects and ionization effects, particularly the case in seawater salts, which contain a large number of elements. The more elements you have in your salt, the more challenging it is to get correct ICP values. Several elements can be analyzed very good in ICP. We call them guiding or indicator elements. Some could have errors higher than 30%. You even can have wrong values up to 100% maybe. From long-term investigations, we know that different elements are consumed in the aquarium depending on each other. These groups change their concentration, as I told you, in the same proportional to each other. Knowing the concentration of these guiding elements, one can calculate the concentration of all other elements in the group. One guiding element, all other elements in the group can be dosed. Yeah. So this is an indirect concentration determination, but it shows a smaller deviation from the actual value for some elements than the direct ICP-OS is doing. So we are better than ICP measurements with dosing in these groups. So this method could expand the capability of ICP testing, would dose more correct, and of course it simplifies the supply of elements in the aquarium. You don't need to buy 36 different solutions. With 5 solutions of these groups, you can dose your whole tank. Makes things much easier. The impact of ICP challenges on the supply of elements in your aquarium, right? Dilution, as I said, is a major problem when you dose each single element. Yeah? You have to measure each single element, and it's a major problem when you dilute it. It's a minor problem if you supply with these element groups. Accuracy, number of elements, you have more elements when you dose in groups, because you can dose even these elements which are very low, which are not able to measure in OES or in MS. Yeah, you can dose many more elements. Matrix impact. There is no matrix impact because we only use the guiding elements for dosing our tank. Depending on ICP method, which wavelengths are clear to measure, we know, so we have only a slightly impact of this. So we could find with this maybe a method to dose more accurate our trace elements in our tank. Conclusion. ICP has challenges which can strongly influence the analysis and their results, right? It's not God-given values in ICP. Properties of the analyzed elements strongly influence the accuracy of their measured values. Yeah? It depends which element you're talking about. And there are ways to overcome these challenges of ICP-driven supply of elements in aquariums, but one need to know the challenges first. Yeah? If you don't know which challenges are there, which problems ICP has, you will always trust each result. You can trust manganese, you can trust iron, but always be careful measuring vanadium or other things. So at the end, maybe it's the idea dosing with brains, thinking about what ICP is good for and what ICP is not so good for. It's a really good thing that we have ICP, but we need to know there are some challenges, and maybe work with some guiding elements, only with the elements we need, could be a good way. So with this I say thank you very much, and I'm open for questions, or if you have the questions later, you will find me for the next 2 hours on this nice booth of TMC, and I could tell you a little bit more about these groups, or I could show you some groups we already developed. So thank you very much.